All right, guys, we shall have a continuation from our previous class. Remember, we talked about the Surds, just our introduction of the Surds and also the applications where we see the addition and subtraction and also the multiplication. So on the case of a division, we do not have that condition direct, like just to divide these sets, but we have it as rationalizing of the denominator. So we want to see how are we going to rationalize the denominator of the given rational terms that we have in this case. So take note, we were saying, of the irrational numbers that we are given here. Remember, we talked about the irrational numbers and the rational numbers. These numbers that are under the square root, these numbers that we see under the square root, every part that we can't determine its square root direct, these are irrational numbers. So if we check here, when your denominator is given as, like on this part, we are given 1 over the square root of 3. Here, 3 over this, there is a what? An irrational number that is in the denominator, the term that we are given. So what we want is to have this as a rational number. A rational number, we are now talking about a 4, a 3. We are now talking about all these numbers, these whole numbers, all right? These are the numbers that we are now referring to and so on. So how is this possible? How can we make this number to be a rational term? That is the question. All right, so this is what you're going to do, considering a condition like what we are given, whereby we are given a single term, a single square root, in this case, like this one. It's a single term. Whenever you are given a single term, you are going to multiply by that term both the numerator and the denominator. That is simply, we are multiplying by 1. So we are going to multiply both the numerator and the denominator by that term. It's a single number that we are given. It's different from this, where there are two terms, like we are subtracting or we are adding. On every condition where you have got a single term like this, you multiply by that. What you focus is what is in the denominator. Remember, we are focusing with what? The denominator. Do not worry about what you see in the numerator there. No. Worry about what you see in the denominator. All right, so that is the idea there. So as we can see that we haven't changed anything, because this whole part, it represents a 1. So if you multiply this by 1, it means you are still having your original question. But what we have just done here is to make sure that the denominator becomes a rational term. How? Okay, let's multiply the numerator as 1 times the square root of 3. It is going to be the square root of 3, just like 1 times x, it's 1x. So which is same as what? X. So if you multiply 1 times the square root of 3, is the same as 1 square root of 3, which is what? The square root of 3. Then here we are multiplying the square root of 3 times the square root of 3. So it follows that if you're multiplying the square roots that are the same, the numbers that are the same under the square root of 3 times the square root of 3, you are going to obtain that number that is under the square root. So let me just put it this way. If you're multiplying the square root of a to the square root of a, you're going to obtain a. Yes, you can combine these two numbers, which is fine. You can multiply the square root of 3 times 3. Like I said before, you can combine these numbers under the square root. You obtain the square root of what? The square root of 9. And the square root of 9, it gives us what? It gives us a 3. So meaning to say, this is going to give us what? This is going to give us a 3. So we are now having a 3. So either from this way, that is multiplying the numbers that are the same under the square root, you get that number, that is the one that is under the square root, or you can combine 3 times 3, you get a 9. The square root of 9 is what? Is a 3. So we have rationalized the denominator. If we check our denominator now, it's a 3. 3 is a whole number. 3 is same as 3 over 1, which is a rational number. Remember, a rational number can be written as a fraction, a over b. So that is to rationalize the denominator. We are supposed to have this as a rational term. So you simply multiply by what you have in the what? In the denominator. So this is going to apply, even if you check on number 2, it's just one and the same thing that we are given there. 3 over the square root of 3. So you're just going to multiply by the square root of 3 over the square root of 3. So if we multiply 3 times the square root of 3, it gives us 3 square root of 3. Just like 3 times x, it gives us what? 3x. So that is the same thing. Just like I explained about the square root of 3 times square root of 3, we are going to obtain what? A 3. But here we can simplify further because these two numbers that we are seeing here, they are outside of the square root. If we check what we are given here, this 3 and these 3, these two numbers, they are outside of the square root. So meaning to say we can cancel these numbers. We remain with a 1. 3 divided by 3, that's a 1. So we've got 1 times the square root of 3, which is the square root of 3. Remember, I talked about this. 1 times x is same as x. So if we are multiplying by 1, we simply obtain that square root of the term that we are given there. All right, so you're going to apply this even when you are given number 3, guys, it's just one and the same thing. If you are to consider this on number 3, this is even if you are given the square root, the square root on top is not affecting this one on the numerator. All right, this is the square root of 2 over the square root of 3. We are focusing not with this numerator, but with what? The denominator. The denominator is the one that we are focusing with, and it is supposed to be what? And it is supposed to be a rational term, a whole number. You're supposed to have the number that we can write as a fraction. So how are we going to do that? It's a simple term. It's a single root that we have. So we're going to multiply by the square root of 3 over the square root of 3. So this is it. Now we are back to our laws of says. Remember, we explained this, that if you're multiplying the root and the root, you combine these numbers from the nth root of a times the nth root of b. This is going to give us what? The nth root of a times b. As long we are having same things or same terms there, if it is a square root, like we've got a square root and a square root, you combine these terms all under the square root. So it's going to be square root of 2 times 3. Everything over what here? Square root of 3 and square root of 3, we said it gives us a 3. Not square root of 3, but just a whole number, which is 3. All right, yes, you can write 3 times 3, which is the square root of 9, but the square root of 9 is what? It's a 3. So meaning to say there, we've got the square root of 3. We've got the square root of 9, which gives us a 3. Then 2 times 3 under the square root, it gives us what? The square root of 6 over 3. It is under the square root. We are not worried about what we have in the numerator in this case. No, we are not worried about this, like I explained before, that our worry is on the what? On the denominator. Are we having what? A rational number in the what? In the denominator. If we have a rational number, that means our solutions are in exact form. All right, so let us try and see another question. We're not going to answer all of these ones. We can even try and check what we have on number 6. All right, let's just see. Number 6 is the same. What you do on number 6, number 5, do the same thing. Number 4 is the same as what we did on number 2 there. So let us just consider number 6. So like I say, do not worry of what is in the numerator. Worry with what? What is in the denominator. So that is going to be 4 plus the square root of 2 over the square root of 2. So considering what is in the denominator, we are given what? A single term. So you multiply by that single term, both the numerator and what? And the denominator. So what does it mean? It means the square root of 2 has to multiply everything on this side. So we are going to have the square root of 2 multiplying 4 plus the square root of 2. All right. So this is everything over the square root of 2 times the square root of 2. This is going to give us a 2. Just like I explained, the square root of a number times the square root of the same number, we get that same number, but out of the square root. Or you can multiply 2 times 2, we get a 4. The square root of 4 is what? That's a 2. So still, we're going to have the same thing. All right. So on the numerator now, you can expand the brackets. All right. That is the square root of 2 times a 4. So it's just 4 times x, which is 4x. So this will be 4 square root of 2. The square root of 2 times the square root of 2. We saw that the square root of 2 multiplied to the square root of 2, it gives us what? It gives us a 2. So it is the same thing even with this part. It is going to give us what? A 2. So that's plus 2 in this case, everything over 2. Yes, it's true that we have simplified this. But remember from our fractions, we talked about this previously, that when we are given fractions of this nature, a plus b over c like this is the same as a over c plus b over c. As long we have it from a single fraction, having a single term, we can be able to separate our numerators to the same term that was in the what? In the denominator. So meaning to say on this part here, we can separate this as the 4 square root of 2 over 2. So this can be written as 4 square root of 2 over 2 plus 2 over 2. We have separated with these two, just like the c that we had there. So this can cancel 4 divided by 2, that's a 2. So we've got 2 square root of 2 plus 2 and 2, it gives us a 1. So that is what we are going to have in simplest form. So be careful on your simplification. Yes, you might have simplified, but you have to simplify your answer to be in simplest form. So you must be able to do that in your simplification to make sure that you reduce your answers to the simplest form. All right, so on a condition like where we have number 7, number 8, number 9, just going to have one question there. On these conditions that we are seeing on these typical questions, let's consider question number 9, where we've got 1 plus the square root of 3 over 3 minus the square root of 2. On these typical questions, when we are now having a sort of an expression there, it's like we have 3 minus x, just like an expression. So in this condition, you simply introduce a negative on the second term, whether the second term is the one with the square root or the second term is the one that is a number like this, you introduce a negative there. So if I introduce a negative here, there's a negative. So negative, it gives us what? A positive. So meaning to say I'm going to multiply by 3 plus the square root of 2, both the numerator and what? The denominator. The one that I introduced here, it gave us what? A positive. So you use it as a positive. Meaning to say for this one, you were going to introduce a negative. It becomes a positive. So it's square root of 3 plus 1 over the square root of 3 plus 1. So if it was a negative, maybe we've got 2 over 1 minus square root of 2 like this. All right, maybe it's a positive like that. You introduce a negative here, it becomes a minus. So it's 1 minus the square root of 2 over 1 minus the square root of 2. So it's not like always the denominator there, you're going to be given negative values. No, it can be a positive. You introduce a negative, it becomes what? A negative. If it is a negative, if you introduce a negative here, it becomes what? A positive. But what you have introduced must affect both the numerator and what? The denominator. That is the idea of the question. All right. So in this case, guys, we can simplify further. That is by rationalizing our denominator. Sorry. So here we can simplify further. Like I said, we just need to multiply the numerators together. So this is it. We are going to multiply the numerators. It's like we've got 1 plus the square root of 3, just like open bracket, and you have 3 plus the square root of 2. 3 plus the square root of 2 like this. Everything is affected. Everything. All right. So here, if you are to consider what is happening here, you can see that there is a difference of 2 squares there. All right. We have got 3 minus square root of 2, 3 plus square root of 2. Consider from your difference of 2 squares, a minus b into a plus b. Where was this one taken from? It was taken from a squared minus b squared, our difference of 2 squares. So this is your a, this is your b, this is your a, this is your b, a minus b, a plus b. So we are going to have a squared minus b squared, a squared, which is 3. So this is going to be 3 squared minus b squared, which is the square root of 2 squared, like that, from the difference of 2 squares concept. Yes, you can expand the brackets 3 minus the square root of 2 into the bracket of 3 plus the square root of 2. Expand the brackets. We are going to obtain the same thing. All right. Expanding the brackets, just like what I'm explaining on this part here, where we are supposed to expand our brackets here. 1 is going to expand everything. It multiplies 3. 1, it multiplies the square root of 2. So if you multiply 1 and the 3, this will be 3 plus 1 times the square root of 2. That is the square root of 2. It's 1 square root of 2, which is the square root of 2. We are done with this one. Remember the FOIL method. All right. Then we move on to the square root of 3. Multiplying also everything is a plus here. So it's going to be distributed here to 3 and also to 2. So if you multiply square root of 3 and 3, that is going to give us 3 square root of 3. Then the square root of 3 and the square root of 2, we said the square root of a number to the square root of another term, we just have to combine them under the same square root. So that is going to be the square root of 3 times 2, which is the square root of 6. All right. So in some cases, you might find terms that are the same. You might find here square root of 3 and square root of 3. On those cases, you have to add. Remember, we talked about addition. Maybe there was 3 square root of 3 plus 2 square root of 3. You can't leave this condition like this. You have to combine because the numbers that are under the square root are the same. It's like you're adding here 3x plus what? Plus 2x. This is x and x. The square root of 3, square root of 3. So if you add 3x plus 2x and you get 5x, because you're simply adding these two numbers, you get 5x. It is the same thing even on this one. You add 3 and 2, you get 5, but the square root of 3. But here they are different, so we can't add these square roots. So we are going to leave as they are. But when on a condition that you've got like terms, then you consider that adding of like terms. But in this case, we do not have. That's why I said we are supposed to also check the previous class that we had where we talked about this condition of addition, where we can add or subtract. All right, then from there, we have got our difference of 2 squares, 3 to the exponent of 2. That is going to give us a 9. That is simply a 9 in this case, minus the square root of 2 squared. So that is going to give us a 2. All right, the square root of 2 squared means the square root of 2 times the square root of 2. Remember, we talked about this, guys. So this is going to give us a 2. So 9 minus 2, that is going to give us what? A 7. So it means this whole part here is going to be divided by 7. So if we check here, there's no need for us to separate, because even if we are to do that, we can't divide anything here. These numbers we can't divide. It is different from the previous case that we had where we can divide. If you were given maybe 9 square root of 2 plus 3 over 3, you can see that we can divide here, we can divide here. That's where there's a need for you to separate. But if this is being divided, let's say here it is being divided by maybe a 10, there's no need for you to separate, because even if you are to do so, you see that we can't divide this 9 and the 10, the 3 and the 10. So you just have to leave it like that. But on a condition where these are common terms, then you can separate. Like I said, on a condition that it can be maybe we are dividing by 3. You can separate because we can divide here, we can divide here. But in this case, we can't. So these are the typical questions that you are supposed to be well equipped in your exams, as long you are working with what? With the surds and the rationalizing of the denominator. Like I said, it's not always that this is going to be a negative. No. Some questions can be a positive, all right? The idea there is the same. Maybe we are given 3 over 1 plus the square root of 2. The idea there is the same. We introduce a negative on the second term. So if we introduce a negative here, it becomes what? A negative. So it's 1 minus the square root of 2 over 1 minus the square root of 2. So the numerator, we are simply multiplying our numerators, all right? 3 is going to multiply everything. In the numerator, that is 1 minus the square root of 2. We have our difference of 2 squares. They are the same, only that the other one has got a negative, the other one has got what? A positive. So we square our a squared, which is 1, minus our b squared, which is the square root of 2 from the difference of 2 squares. So from there, we can have our simplification. All right, that is by 3. 3 times 1, that is going to be 3. 3 times minus the square root of 2 is 3. Square root of 2. All right. Everything is affected. 1 squared, that is 1 times 1, which is 1, minus the square root of 2 squared, which is square root of 2 times square root of 2. We saw that it gave us what? a positive 2. So we can simplify this. That is going to be 3 minus 3 square root of 2 over 1 minus 2. And 1 minus 2 gives us what? Negative 1. So on this case, we can separate, guys. This is a negative 1. We can divide 1 into any term. So meaning to say, we can separate our terms 3 to the minus 1. So you can have 3 over a negative 1 minus 3 square root of 2 over a negative 1. So that this will be negative 3, negative, negative. It becomes a positive. So we've got the 3 square root of 2. So that is how your questions sometimes might be like, whereby you are given a condition whereby you have to introduce a negative and work with that with a negative as it is. All right. From a positive, it is now a negative, meaning if it is a negative, what you use there is going to be a positive, and you introduce on the second term is the one that you are focusing with. All right. The second term, it's not to say it must be under the square root or it must be a number. No, the second term, whether it's a number like I explained here, we are going to apply the same thing, the square root of 3 plus 1 over the square root of 3 plus 1. So I want you to try these questions. There are so many questions that you can put into consideration to see if you are truly understanding this concept that we are talking about.